Good afternoon, everybody. It's a pleasure for me to announce our first guest speaker of the day, Anycie Barakat from Archistar, who will be talking about generative design in AEC. So I'm going to hand off to you, Anycie.
Thanks, Jed. Thanks for having me. Hi, everyone. Thanks for joining my session today. Today, we're going to be looking at how generative design is changing architecture. So my name is Anycie Barakat. I'm the head of generative design at Archistar.ai. We are an Australian-based company that are global, so we're worldwide. My background is in architecture. I have a bachelor's and master's here in Australia, and my main focus is computational design and generative design. So today I'm going to run you through a little bit about Archistar to begin with and how we're really using generative design to increase speed, precision and practicality within the architecture field, also with engineering and construction. So first of all, at Archistar, our main element of the business is how we transform how we build and design. So our entire platform and development process is based on a single digital platform. Everything is web-based, and we have different sections of our platform that we go through every day. So first things first, we use it to find and filter opportunities. We use it to check the planning rules instantly anywhere around the world. We look at researching the potential and the risk of that specific design and that development. From there, we then create and modify design concepts in 3D. We run feasibilities, we run compliance checks, find finance for those specific developments, and then go to submitting for approvals after that. So the idea here is that at Archistar, we really are trying to find, a wholesome product that goes from finding and filtering opportunities all the way through designing, feasibilities, compliance, and right at the end, submitting for approval. So finding that whole design workflow as we go along. So our clients and partners that we currently work with worldwide, a few big names there: CBRE, Colliers, Fraser's Property, all the way through to some of these, larger technology companies that we're familiar with: Autodesk, Rhino, Revit, and so on. And like I said, we are based in Australia. However, we are global, a global company. So in Australia, we look at mainly property developers, architects, designers, real estate agents, all the way down to home builders, banking, and in universities. And from universities, that's kind of where we started. So around the world, we have over 1,000 property and design professionals on our platform, and we actually have a lot of students on our platform. So I think that number's a bit old, but it's around over 70,000 students now on our platform. And the reason is because we actually started off as an online academy. So, so we currently have Archistar Academy still going live, still going strong, and it's in all the major universities around the world. And what that does, it provides online learning for the AEC community on all things to do with generative design, photorealistic rendering, and all the main kind of programs to look at. So Revit, Rhino, Grasshopper, and that's kind of where we started 6 or 7 years ago now. Creating these online tools, really kind of teaching people from the ground up, what the latest and greatest is in generative design. So from there, we kind of said, okay, well, how can we start using our skills to start shifting the curve of what generative design looks like in the in the current field, in the current architecture, engineer, construction community? What does this look like? So when you think of generative design, you think of speeding up manual processes, adding more precision to your design, making a lot of tedious work a lot more practical, a lot easier to use. So how can we start doing this? So if you look at this graph here, this is kind of what we call our project timeline, going from pre-design, back of the napkin sketches, to construction documentation, finally to operation at the end. And in the middle here, we have our traditional workflow, and it kind of sits very heavily, kind of increasing a lot of the work around that construction documentation kind of stage. And this is kind of where the main, that main time taken to actually complete a project is. So From here, the reason it kind of jumps up there is because in that section, this is where you have the main impacts to cost, the main impacts to a cost of design changes. So the further you get across this project timeline, the more it costs to actually make changes to a design. So for example, if I get into this middle section of my construction documentation and I find that actually, it's not going to, my building is not going to be compliant for sunlight or ventilation in this, in this workflow, I'm going to actually have to, make quite a significant change, and that cost of design really does increase quite a bit. So what we do at Archistar, we bring that, that large curve right up to that very initial stage of pre-design. So, we look at, okay, firstly, what does your building look like? Is it in the right orientation? Is it going to comply to all your certain, your certain parameters and your workflows for your country and so on, and bring all that quick back of the napkin sketches right to the very beginning of that construction progress. And the reason we do that is because all those initial costs are quite cheap right at the beginning. So any kind of major changes you take would be right at the beginning there rather than in the middle. And therefore that will reduce costs. It will increase speed later on because you have to make less changes and you'll be more precise in your workflow from that point onwards. So we're very much all about shifting the curve here at Archistar. And the things I'll present to you today will show exactly how we do that. So on our agenda for today, we're going to look at 5 different things here. Firstly, we're going to look at the key concepts for computational and generative design. So starting from the beginners and building our way up. We'll then move on to real-world applications of generative design and architecture, look at some Archistar case studies. We'll go through our designer platform, and then we'll look at how to bring generative design into your everyday workflow. Okay, so let's look at the key concepts and past applications for generative design. So at the beginning, I always try to give a simple explanation of what generative design is because it can get quite complex quite quickly. So for example, if we're looking at here the design of a chair, we say, okay, what is this chair made up of? On the left, it looks like it's, quite a simple geometry there. But on the right-hand side, when you start to break it down, you start to get all these different parameters. So for example, here you have the width of the chair, you have the depth of the chair up to the seat, you have the whole height of the chair, and you have the height of the armrest, and you have the depth here there. So you really can start breaking these down into numbers, into geometry as you go through. And by breaking this down into these parameters, you can then start, creating a system of components that have a relationship with each other. And the benefit of having that is that you say, okay, well, this is my chair, this is my components, and these are my variables now. So what happens is that this chair is now just broken down into geometric relationships, all those different dimensions kind of connected to each other, and these numbers now become your variables. So what happens when you change these variables is that the output now changes. So if I change the width, if I change the depth, if I change the height, I'm going to see different versions of this chair kind of appealing to me. And rather than having just one final output of a chair, I now have a system I can create to create multiple chairs at once. So now we go into what we call simple systems. So rather than having, so this kind of plays definitely into that idea of rather than having one final design, you can start creating a system that can give you, multiple designs. And, rather than going from one chair, you can have, 10, 20, 100 different chairs going forward. So another example here is how we can say, okay, well, how can this circle geometry be affected by this simple radius from a point? So if I start by initially saying, okay, my point is this close to my circle here, what happens if I move my point around? If I move it closer, is it going to shrink? If I move it further away, is it going to increase in size? How is this geometry affected by an external parameter? So what happens if I do this for multiple points, and I drag multiple of these points around? How are these going to change according to the distance from certain points? And we say, okay, well, what if it's all from one point only? And the further I move this away, the larger the circle gets. The closer it is, the smaller the circle gets. And you can see how now we've kind of created this system. of designing, where we have a circle that's linked to a distance from a single point. So how can we start bringing this into, your architecture? And this is kind of where we can bring in components. So we've created a system, and now we're creating components that react to that system. So for example here, if I had a surface here, and it has 3 lines, one on this end, one in the middle, and one on the closest end to us here. What happens if I say, okay, this panel is going to twist according to a certain angle, using my middle line there. And when I twist that, that component changes accordingly. So for example, here, if I bring, 6 or 7 of these panels close together, and they currently have no twist angle, and then all of a sudden I add in an angle, as we twist against there. And you can see how we can quickly start to create this, very parametric design. And this is, with one angle there. What happens if I bring in that point system? And I say, okay, according to this point here, any panel that is closest to this point gets more of a curve. And I can start bringing in, a law curve into this and say, okay, well, if I have a curve and has different points of highs and lows, my parameters are going to change accordingly. And I can start getting these really funky designs out of it. So you can kind of see very quickly how some very simple systems and components can very much affect how we create new architecture, create parametric design, and get to some really funky designs in the workforce. So Grimshaw, they have a very simple system like this where they have different panels with different twists and turns, and you can see how easily you can start creating these really funky designs that are currently out in the world of architecture currently. So even the same thing here. So I guess once you actually start getting to these funky designs, you say, okay, well, actually, how do we build this now? It's like, this is really cool, but what's the next steps from here? How the hell am I going to build this thing? This seems crazy. So this is where parametric design also comes in, especially for the construction industry. So we're very much linking here, architecture, engineering, construction all together in one. So, from here we say, okay, well, I have this design that I've modeled up in 3D. Everything's kind of malleable. I can change it around whenever I want to. I should be able to do the same thing for my engineering and construction. So what we can look here is that we can take this geometry and we can say, okay, well, across this geometry, I'm going to put a central kind of spine in the middle. I'm going to split it up into equal frames and start splitting that geometry at those frames. So my geometry has a thickness. I'm going to start taking out the structure at those different thicknesses there. I'm going to automate it. I'm going to put it into a 2D platform and cut them out in a laser cutter and use that as the structure for my my structural framing profiles. So you can start really kind of very quickly extracting the forms from these new freeform solids. And because you can start doing this, and the technology is out there with robotics, laser cutting, all this new kind of all these new technologies, this now becomes possible to start creating these really cool new designs. And because it's coming directly from the geometry itself, it's fast, and very precise, and evidently very practical at the end of the day. So the same thing here, as you change your design, because you've automated this, it's a system of components, this will automate as well. So any of this manually as you go through, which is great. So another example here, you have a solid brick wall. Each of these bricks is one single component. I can start rotating these. So, I can start putting in on each one of these bricks. They look like bricks, but there's just simple geometry in the architecture and generative design. Well, but I start giving this a rotation angle. And, once you have a rotation angle, then you can start saying, okay, let's bring back that point geometry and start saying, okay, well, the closer you are to this point, the less you're going to rotate. The further you are away, you can rotate it more. And as you go through, you can start seeing how this can be applied in real world applications. There's really kind of very simple components, there's simple geometry, and by applying some very kind of lightweight generative design and parametric design features to this, you can get some funky designs coming in as you go through. So this is with a Gramazio and Cola with ETH Zurich project, which uses exactly this method of designing, which is really cool. And I guess, as we kind of go through and produce all these really cool designs, we do need the engineering and the construction processes to back it up. And this is where you come in, with all your really cool functionality like robotics and laser cutting and all that kind of really cool um, techniques. And as you do need kind of the latest technology to do this sort of stuff. You can't do it manually, but there is a lot of really great technology out there that can start plugging and placing these directly from code in the computer. So for example, here with the robotics, it takes into account, code directly from a computer program and starts actually placing these one by one in a specific order according to that program, which is really cool and also very fast, a lot faster than a manual use of this. So it's really exciting what is possible out there. And this is just using, even the most basic parametric tools that are out there so far. So from here, we start looking at, okay, well, we have these ideas. How can we start using them? Let's explore, these evolving ideas as we go through. So Archistar was originally created by Dr. Benjamin Curry, and he has a PhD in generative design from Australia as well. He's also a global leader in parametric technology. So he started his PhD about generative residential design, and he looked at, okay, well, how can these spaces, in a house, in an apartment, how are they connected to each other? What is the relationship between spaces? So, does my living room have to be connected to my kitchen? How far away can it go? How far away can that be from a corridor, from a bathroom, from a staircase? Does it approach across multiple levels? What does this look like? And how can I start changing this to be, more than just your standard home and your standard residential design? So he built a small plugin in Rhino and Grasshopper and said, okay, well, what if I start just giving this a mind of its own, creating all these different components, giving them different rules, different connections that they can go to, and just start letting it go for gold. And this is kind of where you can get really funky with generative design and architecture and kind of get um, push the limits and really kind of go further than what your traditional thinking of what your standard residential housing is. And the result is that you can get all these different kind of crazy forms coming in. We're really kind of redefining that initial workflow of architecture, what it looks like, and what the possibilities that can be. So this is like 15 different types of options here of what you can potentially do in different spaces. And this was 10, 15 years ago as well. So right at the forefront of when parametric design was kind of very much taking off. You have simple geometry, simple components, all working to produce multiple outputs. So we've taken this, as our base for Archistar, and we've gone ahead and said, okay, well, how can we start implementing this into practice? So, there's very much a lot of stuff you can do that's just very, unusable in architecture. So you can look at, all these kind of crazy designs that will never get built, or you can start using these tools to be very practical and start using it for businesses, and it is becoming more widely acknowledged in the architecture, engineering, construction industry to use parametric design and generative design to speed up processes. So this is a few examples of what we've done for some clients here in Australia and globally. And this is how other companies are using them as well. So for example, Woods Bagger here, you can easily see how they started to create these very much lightweight structures using parametric design. They have canopies, they have tree kind of structures there. You can see they have, gaps between these, um, solid models, freeform models, and they've used the design of those models to directly create structure from them. So we're very much looking away from heavy structure, heavy, kind of like ugly engineering, and moving towards very beautiful architecture based directly off the geometry itself. Other examples were how Populous has created um, a stadium bowl generator. So firstly, it looks at, how can I create this bowl that we're looking at, and they directly use this to create one of their stadium bowls for one of their designs there. That just uses Grasshopper and Rhino, changes all the different parameters around it, and creates a structure from there. Other scenarios we have here with UTS, so University of Technology in Sydney, and the Urban Task Force Australia, they created a program using Rhino and Grasshopper as well, and some code to build up different master planning scenarios in Australia. So they said, okay, well, I need, an X amount of public space, this percentage of residential, this percentage of commercial, and so on. And they said, okay, can you populate 100 different types of designs that fit this criteria? So our company went ahead and said, okay, yep, we can do that, and started outputting all these different designs. And this in itself was 5-10 years old as it is. So this is very much at the forefront of kind of where we started and how we're getting to where we are now. And this was the output of it. So you have in here all the different colors, all the different types of building designs you're looking at, color coded according to what they are. And at the end of the day, you can kind of take these designs and move them into other programs and further develop them from that point onwards to actually be built. So, while a lot of those things, some of them were real life, here are some more recent real life applications of how we've used generative design at Archistar. So very recently, we had a government agency contact us asking, saying, I have this site. I want to develop up all these different options for this site, for this master plan. Can you help us out? So we said, sure. So the challenge we kind of went through here was they had a decommissioned site and that was set to be redeveloped. And they wanted to become, a vibrant community. So we said, okay. So we offered them a solution and said, we'll provide you multiple site design scenarios using our system to complete that site layout. And the result was, we had hundreds of options. We reduced it down to 5 to be the 5 most optimized solutions in that, and that met and exceeded those requirements. So a lot of the requirements we're looking at here, similar to before, we're looking at what percentage of 1 better, 2 better, 3 betters are you reaching? How many total dwellings? Is it receiving enough winter sunlight? Is they cross ventilated? Is there enough open space, and so on? And as you kind of go through each one of these, you can see the designs vary. Some of them significantly, some of them less significantly, just depending on how much information you want to put into it, and add in your bike paths, your trees, your vegetation, view areas, and so on. So we do a lot of that stuff that's kind of quite quick. The project was less than a week, and we get out all this information very quickly for them to decide. Another option we have here is another government architect firm came in and they said, okay, well, I have 15 sites here. I want to test proposed changes to a planning policy that we're going through for an apartment design guideline. And we said, okay, sure. So we provided multiple scenarios to compare generative designs, meaning firstly the existing planning policy, and then again against the new planning policy. So looking at the existing planning policy here, we have all the analytics going forward, and then you look at the new one and see the comparison. For example, here we have with the sunlight. Originally, the first planning policy was from 9 a.m. to 3 p.m., seeing how many apartments were receiving more than 2 hours of sunlight. And then another option is, we adjusted this from 8 a.m. to 4 p.m. to see if there was any difference, to see if it received more sunlight or less sunlight, depending on what it is, and so on. So, there was a bunch of different things, and it wasn't just sunlight, but looking at privacy spacing, building mix, ventilation, and so on, including car parks and all that sort of stuff in there. So you can really start seeing that, while we do have, geometric, very heavy geometric aspects to architecture, but also you can go into analytics and compliance using all the very same systems. So in saying that, we said, okay, well, we have firstly all these really cool design tools. And we started off as an academy. We said, okay, here's all these really cool tools you can use. Going from your very basic Rhino, your Revits, Grasshopper, Python, C#, all that sort of cool stuff. And we said, okay, well, how can we start bringing in architecture, so generative design into the architecture, engineering construction community where you don't have to have the best of the best specific skills to use this stuff. And we said, okay, well, how do we provide generative design for all? So this is where Archistar really kind of came into play here about 5-6 years ago. We said, okay, well, we want to provide practical generative design in an online platform for everyone to use. So your basic, your mum and dad's, everyone to kind of use, your home builders, your developers, your architects, and so on. So we started to create this system where we can start um, providing dwelling types going from low density subdivisions, townhouses, duplexes, terraces, all that sort of low density building designs, and placing it on the platform that you can actually start generating designs by yourself without any other help. You don't require any code, you don't require any further generative skills. All you need to know is you need to put a certain set of parameters into a website, and we will offer you hundreds of solutions in that match those parameters. And we started off small, and we said, okay, let's go through, townhouses, subdivisions, and let's go to high density as well. Let's go to, apartments and commercial as well. So an example of how this would work is that, you look at different townhouses, you have all these different, design libraries, horizontal rows, wrapping around, central driveways. And on the left-hand side, what you're seeing here are different design solutions that pop out automatically within seconds using our system. So it's all web-based. You just log into an account and you see all these different strategies appearing quite quickly on your site that you can start playing around with, which is really cool. And the benefit of that is that, at the beginning, all you have to do is, select different strategies. You don't have to code a single thing. And for every single strategy that we have here, we provide outputs as well. So you see, how many dwellings did it achieve? How many lots? What's my floor space ratios? What's my gross floor area, my footprint area, and so on as you go along. And, as you go through here, there's multiple different types you can start doing. You can do attached housing, you can do manor housing, terrace, and so on, and start building this, for all people to use rather than just the experts. And as you go into, larger scale, high residential designs, you can get really funky with, how you start playing around with these things. So, the outputs you're kind of seeing here, the different colors are assigned to, different unit types. So studios, 1-bedders, 2-bedders. You have your lifts, you have your corridors, your stairs, and so on. And, you can start getting these really funky designs on kind of like, these weird sites. You get the footpaths and so on as you go along. And this, extends out to mixed use designs. Start adding in your retail, your podiums, your commercial, and so on. Start, stepping down these buildings to get more funky designs as you go through. Same thing, with commercial designs. You have your cores, you have your floor plates, you have your kind of, windows on the edges kind of going in from podiums and so on. And all this works directly off a set of parameters. So you simply, input a set of parameters and you can start getting all these designs from here. So once we had, these designs kind of popping out, a lot of people said, okay, well, this is great, but how do I, how can I edit this? Can I move this around? I like that I can, get all these designs, all these different analytics coming out of it, all this sort of stuff. How can I start plugging and playing, with my own designs? So we started developing up these tools where we call, our drawing tools and edit functionality. And what you're seeing here is that, we're starting on a site. We've developed tools that you can start drawing in your own guides. So you can start seeing, okay, I want it, 3 meters from this edge, 6 meters from that edge. I want to join these guides together, and I want to start drawing some buildings, according to these shapes. So what you're seeing here is they're drawing buildings, according to the new guides that we've put in. And the tools are smart enough to tell you actually, if you draw it like this, that part in the middle is not going to work. I'm going to make it red so you know that you need to fix it. And you can start editing, dragging and dropping these different points to get different designs as you go along. And, as you do draw here, the system is smart enough that it actually picks up that this part of the building is too long. I need to split up my building into multiple kind of sections so that the egress is not too far away from each other. And from there, you can build up your different heights. I think it's kind of chopping and changing as you go through here, but You can start, saying, okay, well, I want to draw more guys in here. I want to offset it 12 meters from each side there. And then I want to draw in a building in that leftover space there, so I know it has enough privacy spacing between these buildings. So it really is bringing in that, that CAD, that BIM software all on the web for you to start, playing around with, and very quickly doing a lot of these back of the napkin sketches and getting the information out of it. So, as you're doing this, all this information is being uploading live. You can see, if I go back here, here we have, here I have a target mix that I want to go to. So I want to get 30% one betters, 60% two betters, 10% three betters. With this current design, I'm currently at, these numbers here, 22, 54, whatever it is there. This is my total floor space ratio. I have room to move. I could add more stories on here still, and so on. So, there is kind of like that benefit of having real-time analytics, um, coming back to you from these designs. And, from here as well, you can kind of, work backwards. So I can start off with the design and say, okay, well, initially I wanted to have, if I go back here, initially I wanted to have, 10% or 40% one betters, 60% two betters. I'm going to change my numbers around, and my building is going to update accordingly as well. So you can kind of see how very quickly you can even take an existing design that we've generated or start drawing your own designs, and then very much, working backwards and saying, okay, well, what happens if I change my target config to, this, or, I change my heights to this, what happens? What if I move my buildings here and there? And, how many more apartments do I get? How does this affect my feasibility? Is this now more feasible? And does this work for what I'm trying to do here? So, it does kind of work both ways. You can kind of go, from the ground up, or you can work backwards depending on what you're doing in your current designs there. So I guess, like this is all, very much in our platform. And, it's all live. We have, thousands of users currently on it. But, every day we do get different people asking, okay, well, this is really great. I've kind of got what I wanted here, but I want to take it out and do more work on it. Can I take it out and put it back in? And the answer is yes, like again. So, you can bring it out into as a GLTIF, as a GXF, or into Rhino. Very much coming up, Revit and so on, and more programs. But you can start editing these designs in other platforms. You can export it to different digital twins, get further information, shadows and all that sort of stuff as you go through. And, start creating these really kind of funky designs, bring it back to the system, all weird kind of circular stuff. And as you bring it back in, you get all the same analytics that you would for, a normal design in our system. So an example of, how this would be used on a larger project kind of scale here is that you're saying, okay, well, if I wanted to start off and, anywhere in the world, I wanted to create my own custom site. So I could start doing that. I can start drawing in my own kind of, like basic roads, drawing all the different stuff here, and, start creating different road networks with different widths, different depths, um, as we go along. And, as you go through here, each one of these will split into its own, certain number of lots as you go through. And, when you're happy with that, you can start pressing OK. Well, I want to select, this side here. And I want to start generating, say, for example, some subdivision designs on this one. So I can set my parameters. I can say I want it to be offset, 6 meters from here or 5 meters from there, whatever it is on there. And I want to start placing, different subdivision lots on this specific design. I'm going to quickly choose one that I like, choose it for my project, and then go through and say, okay, I'm going to go in the lot next to it and say, I want to create some townhouse designs on this lot. Same thing, you put in your parameters. You very quickly kind of, change what you're looking for. You can view what your design is compared to other designs directly on the site. And each one of these, have analytics. Does it fit within my building envelope? What does my lot schedule look like? How many dwellings did it receive? And, you can start moving up to larger scales of density design as well. So for residential apartment designs, I want to put my parameters in. I want this percentage of mix. I want minimum sizes and dimensions for my my apartments, my balconies, and what designs can I get from here? So, from here we have different views. We can look at car parks, we can look at shadows, and you can go from basic building designs to some really kind of funky ones as you kind of go through. And the benefit here is that you're not just working on one lot anymore, but you're really kind of looking at what does this look like in comparison, to everything else I'm building in this master plan site. I'm looking at sunlight, I'm looking at ventilation, I'm looking at privacy spacing. Are my apartments too close to each other? Do I need to expand them out? Do I need to, add in different, um, I don't know, shades, whatever it is, to to make it compliant in these areas? And you can start building different types. So we've already done subdivision townhouses, apartments. Now we're looking at commercial buildings, all within this, one sort of master plan area. So the idea here is that, it really can be, you can get quite complex quite quickly. And like, you don't have to have, the greatest skills in the world. You don't have to be the best of the best to start doing this stuff now. It's, we really are kind of bringing this kind of, generative design, parametric design, and, being able to change the internals of a building very quickly to an audience globally, and all around the world, rather than just, the best of the best in the best companies, which is really exciting. And, the more we kind of get into this, the more we'll be able to, write your own code and upload your own things, and really kind of check, is this compliant? And then, run quick feasibilities, put numbers in here. If I sold, my one bed is for this much, my two bed is for this much, and my development costs were this much, would it be feasible for me to do this design on this site? And this is kind of, where the real kind of power of generative design is, and how you can really quickly create these really great designs, with speed, with precision, um, and get to these kind of points of creating really cool designs here. So so this is kind of where we're headed, where we're at now, and there is a lot of stuff coming in the future as well in these cases. But like what you've kind of seen here is, if I go the next page, you can kind of see where the strength is in generative design. So we're looking at analytics, compliance, going through building mix, getting all the kind of relevant data directly out of this, looking at design analytics for sunlight, how many hours per day does each apartment receive? Um, all this kind of standard information comes, automatically with all these designs that get generated. So not just one design, but hundreds of them get this automatic, real-time analytics directly from this, looking at ground shadows. And the idea here is just like, you really want to make quick decisions, right at the very beginning when you're designing. Is my building compliant if I went ahead with this? Will I have to make, I don't want to have to go through 4 months of my project only to know that my building is actually not compliant, and I have to make huge design changes to do this. And, does it have enough deep soil? Is my car park okay? Is it feasible? And by able to bring all this process, within minutes, or doing this within half an hour at the very beginning of your project, you really are. That's really where the speed and precision come into generative design. So this is definitely the way of the future in what we look at for these designs. And it's all about being very clear about what you're looking at. Like, I want to compare different designs together. I want to see my analytics very quickly. I want to see if my site is correct as well. Is this the right site for me? And by able to be doing this all in one platform, this is kind of where Archistar really shines in this area. And at the end, here you can just quickly download on the fly a development due diligence report. It's about a 30-page report. It shows you all the different sum of insights, what's recently sold around the area, what's your planning details, your zoning, your land use, all the way down to value estimates for your land, comparisons for designs, and then more feature designs in detail. So that's kind of where we're at in terms of what we're doing in this space. Yeah. And yeah, so I guess if anyone has any questions, I can answer some questions. But I think that's probably the end of my presentation for tonight. But thank you everyone for joining in and listening to what the latest and greatest in architecture, engineering, and construction is for generative design. So yeah, thank you. Okay, so I can see there's some Q&A questions in there. I'm just trying to see how I can see them in there. I can't actually see them. I'm going to post them in the chat maybe, and I can get back to you on them. Okay, here we go. All right. Okay, so Michelle Vandenberg has asked here, does it use all Grasshopper definitions? No. So at Archistar, we've created our own system of generative tools. So our own kind of geometry libraries and everything from that. It runs on its own servers, all that sort of stuff there. So we did initially start playing around with Rhino and Grasshopper and other C# tools kind of going forward, but to really kind of go global, expand, and run on all these different platforms all around the world, we really did need our own kind of system of designs and our design libraries, and it needed to be hosted on its own servers for it to work globally. Okay, and we have here, okay, what makes Archistar generative instead of just a computational tool? Okay, that's a good question. So a lot of people say that like generative design and computational design are very similar, and I agree. And they do have a lot of kind of similarities. So the difference between having a generative tool at Archistar and just a computational tool, the generative part of it kind of goes where we say, okay, we take into our whole design library, we take into kind of account more parameters, including planning controls, land use, a kind of a wider range of external sources, a database full of designs. It really is kind of a whole system that works together rather than just one tool that looks at specifically, say, sunlight, or specifically ventilation, or just environmental shadows, something like that instead. So it really is a collection of tools and a suite of tools that we've developed up together to make it a whole generative platform rather than just a single computational tool in that case. So we have a question here. Do you see competition in this area come from Autodesk or similar? There's definitely competition around. So we're very aware of kind of everyone around us currently that are doing very similar aspects of the work. So what we've found though is that while some companies are very good at doing specific very specific tools in environmental analytics or building design, there's no one really doing the whole kind of shebang that we're doing. So they're not really going from finding and developing sites, looking at planning rules, compliance in those sections, going all the way to choosing a site that's most feasible for your company, for your needs and requirements, putting designs in that, checking those designs, doing further compliance feasibilities, going that whole way through, all the way up to eventually submitting designs in for compliance and so on as well. So it's good. There's definitely people out there keeping us on our toes, so it's good. We like a good competition. Cool. All right. I think it's the last of those questions there. Cool. All right. Well, thank you everyone for coming in. Thank you for joining me today. Looking forward to, if you have any more questions, send them through, and I'll have a look at those as they come in. Okay, when we export the generated solutions to Rhino, for example, what is the type of these solutions? Are they solid blocks or surfaces or something else? So we recreate the geometry as some of them are mixed. So some of them are extrusions, some of them will be mesh blocks. So solid, definitely all solid blocks. They're not surfaces because we find surfaces are very usually unusable most of the time, especially when they're split up into different options. And it also just depends on what platform we're putting it into as well. If it's exported directly into Rhino, we can export it directly as a as an extrusion, as a usable tool, usable geometry. If it's going into something like a GLTF file, Usually it's in a mesh format. Okay. Cool. No worries. All right. Well, thank you, everyone. It was nice to see you all. Nice. Hope you have a good day. I'll see you later.